Hello model railroaders, I'm Dave. Welcome back to the layout. So today what we're going to try and do is take some Woodland Scenics Fine Ballast, and I've kind of given this a go in a previous video, but I didn't have the quality and grading of sieves that I was able to acquire, and I didn't have a balance that I could actually weigh each fraction out on to determine what the actual content is. So what we're going to do is we're going to take our fine ballast and our sieve set here, and we'll go ahead, dump it in, and see what we get. Now, the Woodland Scenics Fine Ballast, from what I'm able to determine, is essentially dyed nutshell. So, at least that's what their warning is. Allergy caution, contains tree nut byproducts. So, we'll see what their fine ballast does distribute as far as fractionation goes. I do have some more fine ballast in the brown. I don't know if this will actually provide any different answers or not, but once this one's done and I've cleaned the sieves out, I'll give this one a try, and then I'll report to you if there was any real differences. I may have actually lost some of the different fractions when I used this one before, so it'll be interesting taking a unopened package and determining what the breakdown is. So with this all dumped in, it's just a matter, since I have no mechanical capabilities, of just shaking it up until hopefully everything goes through all the different mesh sizes. So what we're looking at is the different pans are 2000 micron, 1180 micron, 1000 micron, 850, 710, 600, 500, which is half a millimeter, 425, 355, 300, and the very last pan is 180 microns, or 0.007 inches. So whatever, I'm more millimeter friendly and micron friendly instead of inches, but I'll give a full breakdown on a spreadsheet when everything's weighed out. So I'll give this another good shake and weigh it up off camera, and we'll come back to the spreadsheet breakdown. So back in a moment. And we're back. So I just want to give you a look at what's in each pan. So the bottom and the ballast is very light, so very little amount doesn't really weigh a whole lot. What's in the bottom pan here is 10 grams. As of yet, I have not calculated out the percentages. I just wanted to give you a look at what was on each of the levels before I did that. This is the 80 pan, so this is the 180 micron or 0.007 inches mesh, and that is holding 32 grams. The 50 mesh screen, which is 300 microns or 0.0117 inches. It is holding 52 grams. And as we go up, we start seeing an increase in the mass. So this is the 45 pan, and that's 355 microns or 0.0139 inches, and it's weighing 86 grams. And we've got the 40 mesh, which is 425 microns or 0.0195 inches. It's 94 grams. So not a whole lot of mass on these pans, just a little bit. Now we get to the 35 mesh screen. Let me just verify that I didn't lose track, which is the 500 micron or 0.0197 inches. Now that has the most mass, which is 372 grams. And I haven't calculated out the total sample weight as of yet. I'll do that based on once I subtract all the each pan's tare to get my total. I'm not looking at this as a laboratory fine where I want to ensure that I've got 100% reclamation of my sample and stuff like that. So I'm not too worried about those numbers. Rough percentages is what I'm looking for. So this would be the 30 pan, which is 600 micron mesh or 0.0234 inches, and it has 16 grams on it. So quite the drop. We're back down to what would be in the very bottom pan, which had 10 grams. So this is the next closest. So of our histogram, we're at the end of the bells, if you will, in that. And then the other pans, which are the 710 microns up to the 2000 microns, are essentially, they're showing some presence, but it's not enough mass to register on the balance that I've got. So it's just showing a little bit all the way up. Now I don't know if these are actually larger particles. I don't believe there's any electrostatic attraction of particles preventing it to drop through the mesh. They probably actually are just traces of larger particles. And if I get this one loose, the last trace showing is the 1180 micron or 0.0469 pan. Very, very little. And then there was nothing that was bigger than 2000 microns or 0.0787 inches. So that kind of gives you a look at what was generated. So hopefully you'll understand how the pan separation works, and give you a little more insight when we look at the percentage between pans. So as we go down, these will just probably not even show up because they're less than a gram. I won't even include these pans. So when we hit our 16 gram pan, which is this one, so this will be the first real reading we get that comes down. So the reading, the percent volume will be between this pan, because it's what's on the top of this pan was able to go through the mesh of this pan, but not through the mesh of this one. So that'll be our percent sample between sizes. And we'll do that all the way down with the predominant size being between the 6,000 micron to 5,000 micron pan. So hopefully that gives you a bit more of an insight of where the numbers I'm going to generate is coming from. And let me go clean this up and crunch some numbers, and we'll be back in a moment. And we're back. So the Woodland Scenics Gray Blend Fine Ballast and the Woodland Scenics Brown Fine Ballast have both been sieved and the data crunched and tabulated, but I want to talk just briefly about prototypical ballast. Now, there are a lot of different resources that you can Google up. I've pulled up this one of the Kentucky Transportation Center Research Report, Ballast Size for Safe Working Conditions in All Railroad Yards and Terminals in Kentucky. This is a summary report from 1995, and it had, I think, about 4 different railroads that were listed. Now, looking at their data, compared to the way I'm reporting it, they're reporting as percent passing. So 100% passing means everything is going through that sieve. Or 80 to 100% passing means 20% is staying on the sieve and 80 or more percent is passing through the sieve. So that kind of gives you an idea. What I'm gathering from this table is that predominantly they're wanting their ballast size, in most cases, between 2 inches to 3/8 of an inch. And that is as well from different other reports that I've Googled, could be even smaller, of 1.5 inches to 1/2 inch. But we'll go with 2 inches to 3/8. So I've drawn up this table from 2.5 to 3/8 and given the equivalent scale size that it would be in HO and N scale to be prototypical. And from that, I've correlated the data against the sieves, the ASTM sieves that I have, and whatever's been bolded is the sieves of interest, if you will. So for N scale, we're looking at what would be a 2.2 inch down to the pan, and in HO it would be from 600 microns down to 180 microns. So grabbing this data and coming over to the fine gray ballast, we can see that even though there are some areas where there's less than 1%, I've used that as 0 because it's too hard to do the percentages. And we start seeing some pan accumulation between 710 to 600, which is 3.5%, which is equivalent to 2 inches prototypical HO. The 6 to 500 is the peak at 37.2, which is pretty close to 1.7 inches in HO, but we're still 3.2 inches in N scale equivalent. 500 to 425, we're 20.3%. That's getting closer to N at 2.6, but still well above, but is 1.4 inches in HO. The next two heaviest are from 425 to 355 microns. That's at 18.6%, giving 2.2 in N. So now we're starting to get into the more N-scale prototypical size, and 1.2% in HO. And then we've got 11.3, 6.9, and 2.2% on the pan, which goes from 1 inch down and from 1.9 inches in N down. Now, looking at the brown fine ballast, and this was the unopened package, we had traces but nothing that was accumulated enough to give a mass change of the pan, so down to the 500 pan, and that was showing at 50%. So where the gray was showing 3.5% here, between the 710 to 600, we're showing nothing, just a trace. Our bulk is 600 to 500, which is equivalent to 1.7 inches in HO or 3.2 in N. And then it breaks down 26.5, 15.4, which is equivalent to 1.4 inches and 1.2 inches. And then drops at that point where we've got just a trace on the pan, and which is 0.6 inches. And from this data, we could say that the fine ballast from Woodland Scenics is HO scale prototypical, based on the range that is being pulled up from various documented sources relating to your, like, CSX, CN, the different railroads. Now, the ballast sizes here in the table also relate to what where the ballast is being used. Like, there's a little note here saying that graduation numbers 24, 25, 3, 4A, and 4 are mainline ballast materials, and numbers 5 and 57 are yard ballast materials. So there is that 2 inch or 2.5 in this case is the complete use of what a major railroad would use in the case of ballast. That's why I used this source rather than another one. It just comes down to that Woodland Scenics Fine Ballast is prototypical for HO. However, it's not for N scale. Now, when you look at this sample of ballast that I've prepped here, the visual acceptability of it, it actually looks fine for N scale. It may be twice the prototypical size, but we're getting to be prototypical in N. The visual differentiation of the particles that we can resolve with our eye is almost too small for our mind to say, yeah, that's ballast, and not something else. It also, I believe, helps that the fine gray is a mix of colors, which sets up some contrast for the eye to help with determining individual particles. So overall, I believe that sticking with the HO prototypical ballast for N scale is actually relevant and looks okay. And when I proceed making my own ballast, I'm going to follow the percentage mix, probably closer to the brown fine ballast, as it makes life a lot easier for me. So I have to start re-sieving everything that I've done with my previous other sieves to bring these fractions together, and then using the scale to weigh out the proper blend and build it up. So that will be a future video, probably closer to the end of this year rather than sooner, I should say. Well, I hope this has been informative, and those who have viewed the video have gotten something out of it. So till the next video, bye for now.